Till now we have discussed the case of trying to find out the efficient frontier, if you remember, considering only n stocks, all of them being risky. That means, they have some standard deviation and some returns. Now, our main question in the next step would be, what if we have one risk free interest rate also, which means basically very simply the bank interest rate, or if you remember the T bill, T91 day bills. So, as already explained, we are aware of the concept of risk free interest rate. The following question is now of more importance to us, is that how does the feasible set look like? Does it change? Does it have the same shape and size? Considering that we have now have a new portfolio where the n risky assets are already there, plus the nth plus 1 is being added. So, now we have basically n plus 1 different type of securities which are there, where n of them are risky and the nth plus 1 is risk free interest rate. So, now consider the diagram in a little bit detail. So, if you see the dotted lines which you have drawn, now do not confuse the dotted lines with the short selling case. If you see the dotted lines, that was the feasible set which you have initially explained, and to make things easier, let us consider that the actual feasible set basically resulted in the frontier, which was this. So, this is the minimum variance point, this is the maximum one which he had, which is corresponding to the case where you had lambda 0, mu 1, lambda 0, which you have already discussed, and any extension would basically be, for this green one would be the short selling case. Now, let us bring for our first instant the nth plus 1, which is risk free interest rate. So, obviously, it will mean that it has no value of risk, that means that point would be along the y axis, which is the return. Now, what do we do with that? Now, let us pause and see that how we can explain that qualitatively. Initially, we had this, say for example, arbitrarily any point which is a combination of n risky assets, where weights are this. Let us consider the weights as they are given, and this is the risk free interest rate. So, what we want to achieve is, now our overall set of feasible region will expand, in the sense, now you have the nth plus 1. So, if you consider simplistically, what you will do is that you will, if you draw a straight line, the blue one, blue and the red one combined together, what is the significance of blue and what is the significance of red? I will come to that within 2 minutes. If you consider and draw tangent with respect to the initial efficient frontier which you have, then it would mean that any combination of two different portfolios, I am using the word portfolio in very general sense. The first portfolio be the combination of all these n risky assets with weights W1 to Wn, and the nth plus 1 is the risk free interest rate. So, if I combine them, any combination when there is no short selling. What is short selling in this case? Let us discuss. There is no short selling between the risk free interest rate and the n number of such risky assets would be the straight line which is tangent to this point, starting from RF. And obviously, if you look the bottom figure, this is again a triangle with the blue and the red extended. So, any region inside the hashed one, which you have the black line hashed one, is basically the feasible region. And again, if you apply the property of non-cessation and basically the property of risk aversion, you will get the straight line, which is where I am drawing the curve. Till this point you have no short selling, and if you basically continue, the red one is basically short selling is there. Now, instantly you will realize that your initial case of n risky assets had an efficient frontier which was curved. Now, the efficient frontier is just a straight line with 2 points which are important for us. Point 1 is the risk free interest rate, and point 2 we already know, because if you remember, when you had solved the MVP, which is the minimum variance point and the maximum point, we had taken that Lagrangian one lambda 0 mu 1 lambda 0. So, with using that you have already found on the maximum point. So, join those maximum point and the risk free interest rate, and immediately you get the efficient frontier for the new case where n number of risky asset plus nth plus 1 is the risk free interest rate. Now, if you are at point this, let us mention as Q, and let us mention this as RF. So, if your portfolio is such that it is in Q, it means that you have invested all your amount of money in n number of risky asset and 0 amount of money is there in the bank. If you are at RF, it means that you have invested all your money in the bank, kept in the bank, and you have not invested any amount of money in the risky assets, n number of risky assets. But now, if you basically extend to the red one, it means that you are borrowing, but borrowing what? You are borrowing from the bank, that means you are going short selling on the bank and trying to invest that extra amount of money in those risky assets. If you are in between, say for example, a midpoint, it means that you invested 50% of your money in risk free interest rate and 50% on the money in Q. So, now our life is much simple. In the initial case, you had a curve which is the efficient frontier with extension for short selling being there, and in this case you have a straight line with the blue one being there is no short selling, which is basically lending. Lending means that I am basically investing some money in the risk free interest rate and some money in the n number of risky assets. And the red one which basically means borrowing, that means I am short selling from the bank, getting some money from the bank and basically trying to invest in the stock market, which are basically n number of risky assets. So, now let us, so this is the Q point which we have and RF or F point which we have already discussed. Now, what is the one fund theorem? In the two fund theorem, we had two stocks or concepts of portfolios, combining them would give you all the set of portfolios which an investor can have. In the one fund theorem, what you need? You do not need two funds, because one is already known to us is the risk free interest rate and another is the Q point which you have already found out. Combine them and any particular investor would always be along the straight line in order to get the best benefit depending on his or her risk profile and the return profile. So, there is a single fund Q of risky assets has that any efficient frontier can be constructed as a combination of the fund which is Q and the risk free interest rate which is R or F, and we combine them, it is a straight line. So, for the benefit obviously we will have different type of assignments, but I would request the students to read this problem. The correlation coefficient existing between two stocks A and B is given as 0.1 and their risk and return profiles are given. The standard deviations and returns are given. The proportions of A and B such that they define a portfolio consisting of A and B having the minimum variance point can be found out using the concept of Lagrangian. What is the value? Once we find out the weights W1 and W2, which is WA and WB, you can multiply by the corresponding return, find out the return the portfolio and use the same the formula for the variances, you can find out the variance of the portfolio. So, these are for the benefit. So, if you read it rather than discussing each and every problem, we will basically discuss the concept and basically I would be open to all the questions which will be asked by the students and we can definitely answer each of them depending on what the actual queries are there with the students. In problem 2 again the same thing. Now, you have three assets, variance covariance is given, these are very theoretical cases just to understand us the cases. So, if you see the variance covariance is given, returns are given, again use the same concept of Lagrangian, find out the minimum variance point, use the concept of Lagrangian, find the one point of Q, join RF and Q, get the efficient frontier for the second case where n number of risky assets and nth plus 1 is risk free, and also you can get the efficient frontier for the case when you have only n number of risky assets. So, there are three scripts, again same problem, consider that from the actual stock market, get them these values and you can basically solve the problem accordingly. Now, our question is how do you find out the efficient frontier for these cases? SS allowed, SS not being allowed and with different combinations of risk free interest rate being there or not there. So, with this small introduction we will try to basically take a pause and in the next class we will basically start with the techniques of how you calculate the efficient frontier given the data and given the set of information that we have already been able to solve the two efficient frontier cases where n number of risky assets were there and n number of risky assets plus the nth one being risk free interest rate. Based on that we have already drawn the efficient frontiers. Thank you.